Now in this video, we are going to take what we learned about basic trig functions and relationships, and we are going to now apply them to solve real-world connections. Now back in geometry, there is something called alternate interior angles when we were discussing transversals. Now that's a lot of big words, but basically what that said about alternate interior angles is that they were equal. So whether you're discussing the angle of elevation or angle of depression, they are actually the exact same angle based off of a postulate in geometry. So what we can do is we can actually take the angle of elevation and actually determine different heights or lengths of real-world connections. So for example, let's say at a point 42.3 feet from the base of a building, the angle of elevation is 75 degrees, and they want to know how tall is the building. So what we are going to do is we are going to actually draw a person, and then we're going to have a building. So let's say this person is some type of feet away from this building. And the angle of elevation is 75 degrees. So if we were to take and create a triangle based off of a person looking up at an angle of elevation to this building, we know that the person is 42.3 feet away from the building, and we know that the angle of elevation to the top is 75 degrees. This becomes our right angle, assuming that the building is at 90 degrees. And we want to know the height of the building. And we have now created a triangle based off this information. This is where SOHCAHTOA comes in. So therefore, according to this angle, this becomes our opposite side, and this becomes our adjacent side. Hypotenuse is not in play in this case. So O and A from SOHCAHTOA, again, I will just write SOHCAHTOA here. O and A represent using tangent. So I can now write an equation. So the tangent of our angle is the opposite divided by the adjacent. Now that we have an equation, we can now solve for x. So to solve for x, we are going to multiply the other side by 42.3, and we will get 157.9 feet would be the height of the building. Next, how far from the door must a ramp begin in order to rise 3 feet with an 8-degree angle of elevation? So if we have a door, that's our door, and we have some ramp. That would become our right angle. So we need the ramp to rise 3 feet. The ramp isn't 3 feet. We need it to actually rise in height of 3 feet, and we know that the angle is 8 degrees. So we want to know how far from the door must the ramp begin in order to rise. So according to this angle, we have our opposite side because it's opposite of the angle, and we have our hypotenuse because it is opposite of the right angle. So O and H represent sine. So the sine of our degree, which is 8, equals the opposite divided by the hypotenuse. We have our variable that is in the denominator. And so the trick in order to get it out is it is going to switch places with the other side. So x is actually going to be on the left, and sine of 8 is going to replace it in the denominator. So in your calculator, you're just going to hit 3 divided by sine of 8. And you will get 21.6 feet. So the ramp needs to start 21.6 feet away from the door in order to be able to rise 3 feet at 8 degrees. Now, there is times where you're going to come across a word problem that is not going to be decimals or a really nice whole number, but instead it is actually going to give it in degree, minute, and second. So for example, if I said that we have a 19 degree, 15 minute, and 30-second angle, which a lot of these you would see mostly in longitude and latitude or bearings with airplanes or ships. Now, in order to put this into a decimal, your calculator actually does the conversion for you. So if you will get out your TI-83 or TI-84 calculator, I will show you how to convert this type of angle into a decimal. Now, when you have your TI-83 and 84 calculator pulled up, the 83 may look a little different from this, but the function buttons, I believe, are going to still be the same. So to type this in the calculator, you're going to type in 19, and then you're going to type in second apps, because you want to get to your angle function, and you want the degree symbol, so you'll hit enter. And now we need the 15 minutes, so you'll type in 15, go back to second apps, where again, you're looking for the angle, and you want the minute symbol. That is not the minute symbol. Let's try that again. Second apps, and you want to go down to the minute symbol. And then the 30 seconds. Now here's where it just looks a little different. The second function is actually not in the angle. It is actually right here above the plus sign, but it's in green. It's not in blue. So to get your second, you are actually going to hit alpha, the plus sign, to get your what looks like quotation marks, and then you hit enter, and that will actually give you, or that will convert your degree, minute, second into a decimal. So this angle represents 19.26 degrees. Now, you can actually convert in the opposite. So let's say for some reason you are working on a problem and they actually want it in longitude and latitude of that. You can actually work backwards. So like, let's say you want to know like what 50.575 degrees is as a degree, minute, second. So what you will do is you would type in 50.575. You would hit second apps, and you would go down to convert. Hit enter, and that will actually give you the degree, minute symbol from a decimal. Now, so now that you know this, we are going to have to use that conversion in this work problem. An A-frame cabin is 26.23 feet high at the center, and the angle makes a 53 degree, 15-minute angle with the roof. I'm sorry, with the base. How wide is the base? So if we were to draw this, we would have an A-frame cabin that is 26. A-frame means it's isosceles, means the roofs are going to be the same length. The height in the middle is 26.23 feet. And the angle that the roof, this would be the roof, that would be the roof, makes with the base would be 53 degrees in 15 minutes. So to figure out what that is, we would need to do 53 degrees in 15 minutes. Hit enter, and it's 53.25. Now we want to know the base complete, but what first we're going to find half of the base, and then we're going to double it, and that will give us our base. So according to this angle, this is your opposite side, and this is your hypotenuse because it's opposite of the right angle. So O and H is going to represent sine. So the sine of 53.25 degrees equals the opposite divided by the hypotenuse. This is where you can use the trick to where if you have a variable that's in the denominator, then it is going to switch places with the other side. So in your calculator, you will get 32.74 feet. Now, that is not your answer. That is only half of the base from there to there. So you will need to double it, and you will get 65.5 feet as the base of the A-frame cabin. From an airplane that has an altitude of 1,200 meters, the angle of depression to a building measures 28 degrees. Find the distance from the plane to the building. So, therefore, let's say we have some airplane. That's my little stick figure airplane. We need to, have some clouds around it because he's in the air. And we have a building that is somewhere on the ground. There is our building. And we know it's a building because there's some grass. Okay, the angle of depression is 28 degrees. Okay, so what we are going to do is we're going to draw a triangle. We are not going to worry about the height of the building right now, even though technically, and that's exactly what we should be doing, is going to the building. But the airplane is 1,200 meters high. That's what altitude means. It means height. And the angle of depression, which is that in this case, is 28 degrees, but we need the angle that is inside the triangle. So therefore, remember us talking at the very beginning of how alternate interior angles are equal. So if the angle of depression is 28 degrees, that is the exact same thing as saying that the angle of elevation is 28 degrees. And we want to know the distance from the actual airplane to the building. So we are wanting to know that distance. We are not wanting to know the ground distance. So be really careful about that. The actual plane to the actual building, we're looking for the hypotenuse in this case. So according to this angle, this is your opposite side, and this is your hypotenuse, which would be sine. So the sine of our angle is going to be the opposite divided by the hypotenuse. The x is in the denominator, and so we are going to switch places. So 1,200 stays, but the sine 28 and x are going to switch places. And put this in the calculator. And you will get 2556.1 meters. And that is how far the airplane is to the actual building. Basically saying that the height of the building is negligent in this case of it doesn't matter of that. Even though it really matters, still it's relatively still going to roughly be about 2,500 meters. A plane flying due east at 265 meters. So let's actually put that. So we have an airplane that is flying east. So that means he's flying that way. Okay. And he is 265 meters above sea level. So we know that the distance is 265 meters in height. The angles of depression, so there's actually two angles of depression, of two ships measure 35 and 25. So we have two ships. We have a ship here. Let that be a ship. And we have a ship here. Let that be a ship. And they are in the water. That is water. Okay. Now, let's see what all it says. The measure of those angles. So we have an angle measuring to the first ship. And then we have an angle measuring to the second ship. Now the angle measuring the first ship is going to be 35 degrees, and the measure of the second ship is going to be 25 degrees. We want to know this distance as our final answer is what we're looking for. But what we're going to have to do is we are actually instead first we are going to find the distances from each ship to the height of the airplane because that creates a right triangle. So we're first going to find this x, and then we're going to find the longer right triangle of basically we're going to find this unknown, and then we will be able to subtract them. So in this case, we are actually going to have two different triangles. We're going to have the first triangle that is at 35 degrees, and then 265. We want to know that. And then we're going to have the second triangle that measures at 25 degrees, and we'll call that y. So once we find these different distances to the altitude of where that airplane is, we will be able to subtract and we'll find the distance between them. So let's start with this one first. According to this angle, this is our opposite side, and this is our adjacent side. And so therefore we'll be using tangent. So the tangent of 35 degrees is going to be the opposite divided by the adjacent. X is in the denominator, and so this is where we use the trick of switching places. And we will get 378.5 meters. And now we're going to do the second one. Again, this is the opposite and this is the adjacent. So we're still going to use tangent, but it's now going to be tangent of 25 degrees equals 265 divided by y. The variable is in the denominator, so we're going to switch places. And we will get 568.3. Now, that is the distance of each ship individually. And now to find the distances between the two ships, we will subtract 568.3 minus 378.5. And we will get 189.8 meters. And so we know that the ships are roughly about 190 meters apart. So I want you to pause the video and attempt this problem, which is very similar to what we just did, and then resume the video to see the answer. We have a cliff that is 380 meters. And Pat is standing on top of it. She sees, or he sees, a ship. And the angle of depression to that ship is 9 degrees. And she wants to know how far is the ship to the cliff. So according to this triangle, we're going to use tangent. So tangent of 9 degrees equals my opposite divided by my adjacent. X is in the denominator. And we will get roughly 2399 meters. Now, Pat sights a second ship beyond the first. So now we have another ship that is in play. So ship number 2. And the angle of depression of that ship is 5 degrees. So now we are going to take the second, and so we know tangent of 5 degrees is the opposite divided by the entire distance. So I'm going to say that could be y. Since the variable is in the denominator, I'm going to switch places with the and we will get roughly 43.4 meters. And now we want to know the distance of the ships are to each other. So we will do 43.4 minus 23.99. And we will get 1944.2 meters distance between the two ships. So, again, in this problem, I would like for you to pause the video, attempt to do this problem on your own, and then hit resume to see the answer. The angle of elevation to the top of an incomplete vertical pillar. Okay, so we have some pillar. It's incomplete, which means they're going to be making it higher. It is 100 meters from its base. Okay, so 100 meters away from its base has an angle of elevation of 42 degrees. Then if they actually complete the pillar, so this is the pillar complete, and if you're 100 meters away, the angle of elevation is now going to be 60 degrees. They want to know how much did it increase by. So if the original was there, and this is the completed, they want to know how much did it increase by. So we will actually subtract these numbers. So according to this, we are looking for the height of the pillar, and then we're looking for the height of the pillar. So this is your opposite, and this is your adjacent. So we're going to use tangent again. So the tangent of 42 degrees equals the opposite divided by the adjacent. So you're going to multiply both sides by 100 to find x. And you'll get 90.04 meters. And then whenever you do it over here, tangent of 60 equals the opposite over adjacent. So you will multiply both sides by tangent. And you will get 173.2 meters. So if the original was 90 meters and then the finished vertical pillar was 173, then how much was the increase by? So you will subtract 173.2 minus 90.04, and you will get 83.16 meters of increase of the vertical pillar.